Hi everybody, welcome to today's video. We're going to be looking at how we can do the ANSYS Primer today. So first thing you'll notice is that I'm in the module shell for ENGD1109. So the first thing we're going to do is download the required file. So if we go to Practice Materials and we go to the ANSYS Primer, you see obviously we've got the ANSYS Primer document here, and I'm just going to download this part. So if we click on this image, you should see that our part file is downloaded. Okay, so what we need to do now is open up Creo Parametric. So I've got Creo Parametric loaded up now, and I'm just going to open that part file. So I'm going to go open. So I'm just going to make my way to my downloads folder. And you see that I've got the part there. So I'm just going to click open. And so we can see this is the part, so it's just basically a simple bike crank component. And in order for us to transfer this into ANSYS, we need to convert it into a neutral file. So to do this, we just go File, Save As, and then what we're going to do is change the type here to Step, and I'm going to change the location as well. So I'm just going to move to my desktop, create a new folder here. Okay, so I've got a step, and we're just going to click OK. So if I now open up that folder, you can see that I've got a step file in here. So I'm now going to open up ANSYS, and we can close down Creo. Okay, so just going to type in Workbench here. Okay, so I've now got ANSYS Workbench open, and we're going to start off by running a static structure analysis. So in the toolbar here, you'll see various different types of analysis that can be run using this software. And so to start a static structural analysis, I'm just going to double click static structural here. And you can see now I have this project schematic area, and I've got a static structural system. And in order for us to run a successful simulation, we need to get a tick mark in all of these cells. Okay, so the first thing I'm going to do is actually import our step file. So if I click on geometry here, and then right click, you can see that I get import geometry. So I'm just going to browse to my step file. So mine's on my desktop in this folder, and I'm going to click open. So now I've attached the geometry to my simulation. So I'm happy with that. It's got a little green tick next to it. It should be fine. Engineering data. So we're just going to go back a step now, and we're just going to double click engineering data. I'm just going to move some of these tabs so we can see what's going on here. Okay, so engineering data is basically the material that you're going to be assigning to the component. So standard, out of the box, it will always attach structural steel as a material to your component. Now, we want to change this to aluminium, so I'm going to show you how you can do it. If you see up here, there's a tab that says Engineering Data Sources. So if we click on that, we've now got a window that shows us lots of different databases that are pre-built into ANSYS. Now, these are just general engineering materials. We can make our own materials, but for now, we're just going to look at using the library materials. So I'm going to click on Granta Design Sample Materials. Sorry, double click on that. And what you're going to see is below here, we've got the outline of the sample materials. So these are all the materials within that database. So if you click on a different one, you'll get different materials here. And I'm just going to scroll towards the top and look for aluminium alloy wrought. Okay. So I like this material. If I click on this, what you'll notice is in the properties box below, these are all the different properties for it. Okay, so you can see we've got the Young's modulus Poisson's ratio for this given material. And for me to add this as a selectable material, I just click the Add button here. Now, if we come out of the engineering data sources, what you'll see here is that we now have two materials that we can select. within our project. So we're going to go back to our project. And okay, so we've got a green tick for engineering data. Now what we're going to do is launch mechanical. So this is the stage where we'll be able to mesh our component and add our boundary conditions. So if I click on model, right click, and then go edit. Okay, so now we have the mechanical module open. I'm just going to get rid of this little pop-up. And what we can see is we've got our part successfully imported. And before we start to generate a mesh or anything like that, we just need to check the material assignment. So if we click on geometry here in the project outline, click the little plus sign next to it, you'll see this is our actual body. So I'll click on that. And then down in this details panel below here, you'll see that it says material assignment. Okay, so it says material assignment, and at the minute it's structural steel. So if I click on structural steel, click on the little arrow next to it, I can change this to the aluminium alloy that I selected earlier. So I'm going to click that. So now I've changed the material to aluminium. And now what we can do is mesh our component. So if we click on mesh here, what you'll notice within ANSYS is that anytime you click something within the project outline, so if I go back to geometry, we get a new context menu. So we get a contextualized menu that tells us about some of the actions that we can perform when we're in this part of our simulation. So if I click on mesh, we get our mesh controls here. And to generate a mesh, it's really straightforward. We just click generate. And what it will do is generate what it deems to be a sufficient mesh to capture your geometry. Something to note here. So while mesh is highlighted, if we come down to the details box here and click on the little plus sign next to statistics, it shows us how many nodes and elements have been generated for this part. So this is important when you're using the student version. There is a limit of 32k nodes and elements. Okay, so this is quite a coarse mesh, and what I want to do is actually refine it. So while mesh is highlighted, I'm just going to click sizing here. I've got this new sizing constraint attached to my mesh. Now, if we come down to the details box, we've got these two yellow fields. So anytime you see a yellow field in ANSYS, it means that you need to import some kind of information. So for this sizing constraint, we can see that we've got geometry. So it's looking for some geometry. So if I click here, and at the moment, if I look at my graphics tools, I'm on surface. Now I want to set a element size to the whole body. So I'm going to change this to body. And then I'm going to click on the component. It should be highlighted all green, so the whole component's green. And then we click apply. Okay, so the whole body now has been highlighted, and you'll see that the mesh has turned pink. So that means that the mesh is obsolete that was originally generated. And we're going to change the element size. So the default element size is 10.351. I'm going to change this to 4 millimeters. So I'm just going to click on the box, press 4, press enter. And then if we come to the top here, we can click update. And so this will apply a new mesh that we can see is much finer and should give us better results. Again, if we have a look at statistics, you can see that we've greatly increased our nodes and elements. So bear in mind that with analysis like this, there is always the trade-off between, accuracy and time. So the finer your mesh, the longer it will take. So we've meshed the component. Now we need to apply some boundary conditions. So if we click on static structural here, you'll see that our toolbar along the top changes again. And now we've got different loads and supports that can be applied to this part. So the first thing I'm going to do is apply a fixed support. So click fixed here. And you can see here it's looking, if I look down in the details for my fixed support, it's looking for some geometry. So this time I'm going to use the face tool. So it's already selected that for me. And I'm going to select these inner surfaces. So if I just click that surface, let go, rotate the screen, press Control, click that surface. I've got both surfaces highlighted, click Apply, and I've now got a fixed boundary condition at the center of that hole. Now I'm going to apply a force. So if I come to the top toolbar and click Force, again you can see a force here. I need to give it some geometry. So I'm going to select these surfaces inside this hole. Click Apply. Okay. And now we need to, obviously, force is a vector, so we need to give it a direction and a magnitude. So what we need to do here is, at the moment, if we have a look at the definition, it's saying that it's going to be defined by a vector. So we would have to provide it the direction using an edge or some kind of feature on the component. Now that could be quite difficult. It could be easy, depends on the part that you're using. Now, I'm just going to change this. So at the minute it says vector here. So if I click that, click this little drop down, we can change this to components. So now you can see that we've got different components, X, Y, and Z, and they correlate to the coordinate system on the corner of the screen here. So if I want to apply a force that's pushing down here, that would be in the Z direction. And obviously Z up is positive. So if I say minus 1000 newtons here, I should get an arrow pointing down. And that's what I've got. Okay. Now, if we click back on static structural here, it gives us a bit of an overview of everything that we've done. So we've got our nice meshed component, we've got a fixed boundary condition, and we've got a force applied to this hole here. So we've got ticks in pretty much everywhere that we need, and we can now solve this. So if we click at the top here, solve, it will now go through the process of solving our problem. You can see we get a solution status down at the bottom here. Okay, so we didn't get any warnings, no issues, and you can see that we've got ticks in all of these boxes. So now we've solved this, what we want to do is analyze the results. So if I click on solution here, you'll see again we get a new contextual bar along the top, and we can start adding some post-processing. So the first thing I'm going to do is add some stress results. I'm going to click equivalent on ANSYS, and I'd quite like to know the deformation as well. Okay, so I'm going to click deformation and click total. Okay, so we've got our two solutions here that we would like to evaluate. So to evaluate these, we just click on solution, and if we right click, you can see evaluate all results. Okay, we've got little ticks next to them, so that's been successful. And we can now have a look at what the stress map looks like. So if we click here, you can see, okay, we're getting not much stress in the middle. It's mostly fixed around, most of it is around our fixed constraint. Okay, it's what we would expect, it's just a cantilever, so most of the stress should be around this point here. We can also look at the deformation. Okay, so obviously this is going to deflect most where the force is being applied, and where it's fixed, there's no deformation. Okay, so an important thing to remember here is that, making sure that if you're going to capture any images, that you've got a large legend so that people actually know what these colours mean. Another thing we should look at, so if I go back to stress here, let's just square this up. There's a graph panel at the bottom here, and you can click play, and that will animate for you, so you can see how so the direction. So this is quite good as a sanity check to check that your analysis is working correctly. You can stop that as well. If you want to, you can even output this as different kinds of files. You can output it as a video file, some kind of GIF. Okay, and you can do the same with the deformation, so we can see how this changes as well. Okay, so that's basically the ANSYS Primer. So it's got you up and running using a static structural analysis.